In this problem, I need to find the center, foci, and vertices of the ellipse that's given here. We have 49x squared plus y squared minus 784x plus 3087 equals 0. In order to find all these components of the ellipse, what I'll do first is rewrite my terms with the x terms grouped together. If I had more than one y term, I would group them together and get the constant term on the right-hand side of the equation. So I have 49x squared minus 784x plus y squared, and then the 3087 is subtracted over to the right side, and I have equals negative 3087. Now I'll complete the square for the x terms. The y term is fine the way it is, and the constant term we just leave alone for the moment. So I have 49x squared minus 784x. The first thing I need to do is factor out that 49, and that gives me x squared minus 16x. So I'll add 64 inside the parentheses, because half of 16 is 8, and you square 8 and you get 64. Let's put that plus y squared on the end there, equals negative 3087. But this equation is not the same as the previous equation because I just added something to the left-hand side. I have to balance the right-hand side with the same amount. So I don't add 64 over to the right side. That's what people will usually think. But what we actually have is 49 times 64. So I have to multiply those, and that's what I added to the left side, and then I add that on to the right side. Okay. So 49 times 64 is 3,136. So I add that on to the right side. And now I'll just simplify and factor, and that gives me 49 times x minus 8 quantity squared plus y squared equals. And on the right side, we subtract and we get 49. There you go. This is still not in standard form because we need to have whatever's on the left side equal 1. So I'll divide both sides by 49, and that will give me 1 on the right side. So on the left-hand side, the 49 times x minus 8 quantity squared, the 49 in front will cancel with the 49 in the denominator. So this gives me x minus 8 quantity squared, and I like to write that over 1. Obviously, it's not absolutely necessary, but it's nice to have the ellipse in this standard form. It just makes it a little bit easier to do the problem. And then we have y squared, and that's over 49. And that all equals 1. So now I'm in standard form, and I'm ready to answer the questions. What are the center, foci, and vertices of the ellipse? Now for this ellipse, the standard form is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. And the reason why I know the a squared goes under the y minus k squared is because the denominator of the y squared term is larger than the denominator of the x squared term. So at this point, I can write the center of the ellipse. And the center is HK. So I've got x minus 8 quantity squared, and that would make h 8. Keep in mind, it's always x minus h and y minus k, and so you have to be careful with the sign there. So we have 8 for the x component of the center, and the y component, or k, would just be 0 in this particular case. So we have the center at 8, 0. We have to start with the center because we're going to find the foci and the vertices based off of that center. So before I continue on and find the foci and the vertices, I'll need to know what A, B, and C are for this ellipse. So we know that A squared is 49, which makes A 7. B squared is 1, which makes B 1. And A squared minus B squared is equal to C squared. So that makes C squared 48. And to find C then, I just take the square root of both sides, and I'm not worried about the plus minus because we're going to include that in a second. So I just make C the positive root, and the square root of 48 I can write as 4 times the square root of 3. So now the foci, to find those, all I have to do is add and subtract the value of C from the y value of the center. How do I know which one? It all comes down to which denominator was larger. So whatever has the a squared, in this case y, because 49 is larger than 1, so everything's going to be working off of the y value of the center. So the x-coordinate of both of my foci is going to be 8. And then we have 0, and that's going to be plus or minus the value of c. So I can just write plus or minus 4 square roots of 3. And I can leave it in this form. This gives both foci. And then my vertices, we're going to do kind of the same thing, but we're going to take 0 plus or minus the value of a, which in this case is 7. And this I do have to work out because the arithmetic you can do. So it's 8 plus or minus 7. And so now I have the center, foci, and vertices of my ellipse. And that's all I need.